Hi everybody, welcome to section 9.2a, solving quadratics by graphing. So we've been solving quadratics, we've been graphing quadratics. Some of you we talked about to solve or not to solve. If you understand solving, you're good. If you don't understand solving, we can find the solutions a different way using the graph. So you'd make your XY table. I'm going to kind of jump through the graphing part of it because I want to talk about the solutions and the solving them. So first of all, everybody knows that the standard form of a quadratic is ax squared plus bx plus c. At this point, I hope that everybody knows that the vertex form of a quadratic is y equals a multiplied by the difference of x minus h squared plus k. We talked about that in section 9.3, and we did the activity. Sometimes a quadratic equation isn't factorable, so when you try the square method or what multiplies to a times c but adds to b, you can't find anything that works. So we can still find the solutions using a graph. And we talked about it, but kind of we're looking at it from the other direction now. So I said when we graphed in section 9.1, we said you could find the solutions, and those solutions are two separate points on the x-axis. So the solutions of a quadratic equation are really x-intercepts. We also call them roots, or we call them zeros. So solutions, x-intercepts, roots, or zeros. So in this section that we're saying is called solving quadratic equations by graphing, they're having you go the other direction. They're saying, okay, put this graph on the coordinate plane, graph the parabola, and look at the x-intercepts and tell me what those are because those are the solutions, right? So there's four situations that can occur when you graph. You've got yourself a parabola. I'm going to make mine have a maximum. So my parabola is opening down, looks more like an umbrella. If we know that the x-axis is where we look to find these solutions, the roots, the zeros, or the x-intercepts, let's think about the four things that can occur. The first thing is what I put up here. How many places does my parabola touch the x-axis? Even if I slide it around, right, I have two rational roots. Rational tells you that they hit, I don't know if hit is the right word. That seems a bit violent, doesn't it? That they touch at exact grid marks. I'll put exact after it. I'm going to skip down here to number 4. Excuse me, because another situation that can occur is two irrational roots. Notice my parabola is still touching. I could even put grid marks on here. So if I do this, my parabola is touching exactly at -2 and +3. Two rational or exact roots. Things like 1/2 and 2.75, those are also rational numbers. Remember, we talked about rational numbers at the beginning of the year. Two irrational roots means it still touches in two places, but it's like in between. It's inexact. It might be 1/2. It might be 0.4963784992. We don't know. So it still touches in two places, but they are irrational, not exact. They don't make sense. They don't touch at a grid mark. Or at your actual numbers on your ordered pairs. Another thing that can happen is kind of a cool one. It's called a double root. It's kind of misleading. A double root means that you've got one x-intercept. So if I make my parabola touch at only +2, it's got one root, Technically what that means, if we factored, we'd have two exact factors like x minus 2 and x minus 2, or some of you wrote it as x minus 2 quantity squared. So you actually only have one solution because it only touches the graph in one place. And last but not least, this is the crazy situation. My parabola might not touch that x-axis at all. There are no real roots. We've got nothing. There's no place that my parabola touches the x-axis. So we've got no solutions. No x-intercepts, no zeros. So here's one little thing that you might make a little mental note. If it's got two irrational roots, you're going to be able to factor. If it's got a double root, you're going to be able to factor. If it's got no real roots or irrational, you're going to tell me that this is prime when you try to factor. Can't. So to solve or not to solve, if you're trying to factor those using the square method or the multiplies to a times c and adds to b method, you're not going to have any luck with 3 and 4. You're going to have to make a table. All right. So I don't want to do a whole ton with the examples that we've got here because I want you to have a chance to go through. We've been graphing. I do want to make a note though, and I should have changed my examples. I should have said something about vertex form in here. I should have had some equations at vertex form. So two rational roots, remember, the parabola touches in two places. Parabola touches at two exact places. I'm not going to graph this. Feel free to do so. A double root. This one, the parabola touches, and when I say touches, I'm talking, remember, about the x-axis. Touches x-axis in one exact point. We could solve that. Notice there's a problem here. It's not equal to 0. So I would start by adding 9 to both sides. When I factor, find axis of symmetry, whoops, find the vertex, I would make sure that it's equal to 0. That's a rule. There's a problem with that problem. No real roots means that when you go to find solutions, you cannot find them. The parabola doesn't touch the x-axis. And again, I should have put like this equation, x squared plus 2x plus 3, I should have put it in vertex form. We can still factor, or we can still graph it. We can find the axis of symmetry, the vertex, the y-intercept. We have to do some work to find the y-intercept. We could still find ordered pairs by making a table. Put the vertex in the middle. But once we graph that, we know that this graph is going to be floating up in space. It will not touch the x-axis. All the other stuff, though, you can still find. And last but not least, irrational roots. There'll be 2 of them. I should have put 2 irrational roots. Parabola touches touches x-axis. Forgot what that word was. X-axis at I'll put irrational points. So notice I have the equation x squared minus 4x plus 2 equals 0. Solve that by graphing. If integral roots cannot be found, estimate the roots. So let's do this one. So first of all, axis of symmetry. Everybody remembers how to find the axis of symmetry, right? X equals, if you don't know negative b over 2a by now, we're in big trouble. So for this one, when I go to set that up, I'm going to say that's equal to a positive 4 over 2 times 1. So I'm going to say my axis of symmetry is x equals 2. My vertex I know is going to be at 2 something. I'm going to plug that 2 in. So 2 squared is 4 minus 8 plus 2. Instead of thinking of it as an equal 0, I just think of it as an equal y. We did that way back when we were solving linear equations by graphing. Interchange the equals 0 and equals y. So my vertex should be at 2, -2 when I do the math. Y-intercept, we all know that's the c value. And solutions, I'm not even going to try. I'm going to make myself an xy table. I'm going to put my vertex 2, -2 in the middle. I'm going to count down 2 and up 2. You can pick any numbers you want. That's the whole point of the domain is all reals. You can pick anything. I just like to have that symmetry. So when I put a 0 in for this equation, 0 squared minus 0 plus 2 is 2. When I put a 1 in, I get 1 minus 4 plus 2. That looks like it's going to be a -1. When I put a 2 in, I got my -2. When I put a 3 in, I'm going to have 3 squared is 9 minus 12 plus 2. That looks like a -1. When I put a 4 in, I'm going to have 4 squared or 16 minus 16 plus 2, so I've got a 2. So I've got 5 points. I've got my axis of symmetry. So x equals 2 is right here. Remember, that's a dotted vertical line for my axis of symmetry. My vertex is at over 2, down 2. If your vertex doesn't land on your dotted axis of symmetry, you did something wrong. So here's my vertex. I'm going to put my y-intercept is at 2. Use symmetry. I know that my mirror image has to be right there. And I'm going to just use my ordered pairs. I actually ended up reusing a couple things. So over 0, up 2 is my y-intercept. It's also this first ordered pair. Over 1, up 1. Over 3, oh, sorry, not up 1. Over 1, down 1. Over 3, down 1. And then my mirror image, 4, 2, which I already had on there. So connect these dots. Put your parabola in there. Now look at your x-axis. There's one solution right here. There's one solution right here. Remember, the solutions are the x-intercepts. So that's not really a very nice, neither one of them are very nice points. So for the solutions, I'm going to say that one solution is, looks like it's between 0 and 1. Between 0 and 1. I don't know. It might be a half. It might be a third. It might be a quarter. It might be, I don't know. But it's between 0 and 1.
Teachers, please excuse the interruption.
Sorry about that interruption. Never mind. So we said one solution was between 0 and 1. It looks to me like the other one is in between 3 and 4. That's the best I can do for, sorry for that interruption. Looks to me like the other one's between 3 and 4. That's the best I can do as far as telling exactly what my solutions are. Uh-oh, class is over. Don't leave yet. We've got one last thing to talk about, and that is our lesson summary and practice problem. Feel free to go back and do the graphs for the other ones. It tells you how many roots you should have and if they're exact or not exact. But for the lesson summary, please tell me, out of the 4 situations that can occur for solutions, x-intercepts, roots, or zeros, 2 can be factored and 2 cannot. How does the factoring thing, if they can be factored, relate to x-intercepts? What does it mean if they cannot be factored? So how do x-intercepts and factoring relate to each other? And practice problem. You don't necessarily have to graph it, but find the stuff that you would find to graph it. I should have put this in vertex form, I apologize. But I've got an a y equals x squared plus 4x plus 4. Find me the axis of symmetry, the vertex, the y-intercept, and the solutions. Find those solutions by doing our old-fashioned factoring, or by graphing it. And feel free to use one of the graphs above or grab a piece of graph paper or make one up for yourself. But when you're looking for solutions on a graph, you have to use very specific grid marks because you have to see them. So go ahead and answer those two questions, lesson summary and the practice problem, and we will talk about section 9 2A next time.